All right, what do you have for an answer for this first one?
The water rips apart.
Water rips it apart? Okay. Do you have a reason as to why?
The polar nature of water.
Yeah, water is polar. Okay. 3 ionic and 3 that are soluble and insoluble. So give me an ionic compound that's soluble. Lithium what?
Carbonate.
Carbonate. There we go. Lithium carbonate. How about another one? Sodium sulfate? Okay. Something else?
Hydrochloric acid.
Not an ionic compound,
Hydrogen.
because it's 2 nonmetals. Say again?
Acetic acid.
Not an ionic compound. Nonmetals, right? I already have a sodium. You should be able to name like 100 in like,
Scandium phosphate.
no, it's not soluble.
Hydroxide.
That's not a compound, that's a polyatomic ion.
Hydrochloric acid.
That's, and it's not ionic, and we already said that one.
Sorry, oh boy, you were feeling miserably.
What? Sure, magnesium chloride. All right, how about 3 that are insoluble?
Mercury,
I've already got a chloride.
calcium phosphate.
Okay. Something else? So she said mercury chloride, and I said you can't use that one because I already had a chloride. You all should throw out one of 3 different names, like instantaneously. What should those 3 different names be?
Mercury, silver, iron.
Mercury to,
Fluoride.
okay, she said chloride. So what are the other 3? Mercury to fluoride, mercury to bromide, mercury to iodide, right? Mendeleev saw that they all did the exact same thing, so they're all going to be the same insoluble compound. So I'll put mercury, oops, mercury to fluoride. And another one, insoluble? Silver what?
Sulfide.
Silver sulfide? Okay. Ag2S. Alrighty. Let's balance some equations and whatnot. So how do we balance this first one? Say again? 11 in front of the water, okay. So now we balanced out our H's and our O's, and then a 12 in front of the carbon. Well, that one was easy. States, the first one? Negatory. Solid. Why do you think it's a solid? What do you think it is? Ethanol? Oh goodness, no. Ethanol is tiny. This is huge on a molecular scale. What does it kind of look like? It's got carbons, hydrogens, and oxygens.
Looks like a sugar.
It's a sugar. It's a carbohydrate. And so a big old carbohydrate like this is going to be a solid. Yeah. And how about for the C?
Solid.
And for the water? Okay. Any ionic compounds there? Nothing gets circled. Okay. Next one. How do I balance this one?
3 O2,
There's 3 oxygens.
2 CO2,
Okay.
and 3 H2O.
4, 5, 6, 7, 6, 7, 3, and 3. Yeah, that looks good. Okay, states?
That's a liquid, that's ethanol, right?
It could be ethanol. It also could be acetone. Regardless, they're both liquids. So, yeah. Oxygen, a gas, CO2, a gas, and water, I'll just put as a liquid. Am I circling anything? Nope. Okay, balancing out the next one. A hint with this, when you have polyatomic ions, if the polyatomic ion is on both sides of the equation, meaning it didn't break down, I still have it on both sides, then you can treat that polyatomic ion as one whole thing. So right off the bat, I can make this really easy on myself. I see 2 ammonium ions, right? So then I can drop a 2 right here, and now I've taken care of the ammoniums completely. And then from there, I'm done.
Oh my god,
That one was easy.
I made that way too
I
hard
did
on
too,
myself.
look at front.
We okay with that being finished? States for the first one? Okay. Next one? Next one? And last one? And ionics? All of them. They should all be circled. Okay.
Solid because they are salts, is what's their?
They're ionic compounds. And you don't see any water present, so you can't say if they're soluble or aqueous or not. All right, next one. The hydroxide didn't stay on both sides, so you can't just manage it with hydroxides. So 1 aluminum, 1 sodium. Looks like 4 oxygens. And
2 H2O.
that's it. Is that really it? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Wow, that was really easy. Okay. States. First one. Next one. Next one. Last one. Circle. First 3, right? That metal didn't go anywhere. Okay. Balancing the next one. If I put a 2 right here, I balanced out my phosphates. How does that affect this? And then if I put a 3 here, I balanced out my irons. And that leaves me with 6 sodiums and 6 chlorines. All right, so then I just put a 6 there. I'm good to go. Alrighty. Solid, 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 circle, 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 circle. Okay. And the last one. One sulfur, 1 sulfur. 4 oxygens. So I definitely need at least a 4 right there. That'll give me H.
Throw 4 in front of HI.
And then a
So that's
2
8, 9, 10. And okay, and there's 2 over there. All right, so then I've got taken care of my 10. No, that's not 10.
No, you need
I need an 8 here.
5 in front of the iodine.
And then that'll give me a 5? How about a 4?
Sorry.
So that's 1 and 2, and a sulfur and a sulfur, and 8 and 8. Yeah, that looks good. Okay, states?
All solids that water is losing.
aqueous, gas, solid, liquid.
That's an acid, right?
The first two are acids, right? Sulfuric and hydroiodic, and then the next one is H2S. We talked about that already. That's stinky smell, rotten egg smell, small sulfur molecules, stinky smell, gases. The iodine is a solid on the periodic table, and then it's water. Am I circling anything?
The first one.
Acid. Not ionic acid. Nothing. Okay.